Okay, so this video we're going to talk about operations with rational numbers, and we'll probably cover all 4 operations in one video, even if it goes over my special time of 15 minutes that I like. So, what is a rational number? Well, looks like this. Q is the double vision Q, I think some people call it, is the symbol for rational numbers. If you want to know why, ask me. Okay, what Q looks like is you have to use set builder notation. Q is all numbers that look like A over B, such that A is an element of integers. B is also an integer, but B cannot be 0. So any number that looks like that. So that means we can make a number that looks like A over B, where A and B are integers, but B can't be 0. So in other words, I'll pick an integer. 8 is an integer, and 12 is. Okay, so that's a rational number. This is not a rational number, because B cannot be 0. So not negative 3 over 8. That is, because negative 3 is an integer, 8 is an integer. So that's basically what the rational numbers look like. This has to be an integer, that has to be an integer, but that can't be 0. Now the difference between rational number and a fraction. So let's see. I'll write fraction here. Rational number. I'll abbreviate it like this. Okay, so the reason I'm pointing out this distinction is because sometimes I'll actually say fraction. In this video, though, or pretty much any other video, if I use the word fraction, I really mean rational number. There is a difference. A rational number, that's a rational number. A over B, such that A is an integer, B is an integer, but B cannot equal 0. Fraction is any number over any other number. So, in other words, pi over 4 is a fraction. But that's not a rational number, though, because pi is not a rational number. So, if I use the word fraction, pretty much always going to be talking about rational numbers. I'll try to say rational number if I mean rational number. But if I use the word fraction, I'm probably still talking about rational numbers. Alright, so that's what a rational number is. Basically, like I said, it's a type of fraction. Now, even integers, though, like 8 is a rational number, because it can be written 8 over 1. So, rational numbers also include integers. Alright, so we're going to talk about adding. I would like somebody to give me 2 rational numbers, but nobody's here, so I'll just make up ones. 3 over 7 plus 4 over 10. Yeah, that could be a good one, I guess. So, when you add, and this is for adding and subtracting, addition. When you add 2 rational numbers, you need to have common denominator. That's why we talked about least common multiple. If I say we, I made a video of it. But we would have talked about it, and if we have any classes, virtual classes online, I'll probably talk about it. That's why we talked about LCM. You need to find the least common multiple of 7 and 10. And that's also why it's sometimes called LCD, is because the reason is that we want to make the denominators the same. So in this example, like that's why I don't like making up my own examples. I'd rather have you give me examples. But in this example, you can see that this fraction here is not simplified. So one thing you could do first is you could simplify everything. Well, 3 over 7 is already simplified. And you could figure that out if you found the GCF of 3 and 7 is 1, which means you can't simplify it. 4 over 10 though, 2 goes into both. So this is actually 2 over 5. You could write it as 2 over 5. Now, notice that we still don't have the denominators in common. So we have to find the least common multiple of 5 and 7. Well, I'm going to do this I don't want to call it the hard way, but it's uninteresting if you do it the better way. I'm going to just list out all multiples, not all, but some of the multiples of 5. I like to do things 3 at a time. Don't want to skip any. So I don't see anything in common yet, so I'm going to do 3 more. Three more. Three more. Except for when I do this one right here, I see that we have something in common. Hopefully you can see that in red. Maybe zoom in. I think you can zoom on YouTube. Hopefully you can. So 35 is what I want the denominators to be. So I'm going to multiply this denominator by 5. Let me write it a little bit bigger. But you can't just multiply the bottom by 5 without multiplying the top by 5 because that would change the value. So you have to multiply the top and bottom by 5. Here you have to multiply top and bottom by 7. So you're going to get 15 over 35 plus 14 over 35. Now, when you add fractions, rational numbers, you just add the top. So 15 plus 14, we already know how to add integers, 29. Then the bottom stays the same. Since we simplified everything before we did the addition, this is more likely than not. I think it always actually will be in the lowest terms. But I have to think about that for a while, and I don't want to. I want to just make this video. You should always look at your answer, though, just in case. Make sure that you don't think it can be simplified. This can't be simplified, so we're good. So that's addition. You need to find least common multiple to find the least common denominator. When you're adding, once you have them the same, the denominator is the same, you just add the numerators, then leave the denominator as whatever it is. Then, like I said, you should always check to make sure that that can't be simplified. If we had not simplified this first, this would need to be simplified. So you should check because maybe you forgot to simplify this first. This will definitely need to be simplified then. Alright, so for subtraction, I can use the same. Now I want to use different numbers because I want to find the least common multiple again. So I should have like my calculator out and have it give me random numbers, but let's see. 7 over 15. Oh, we're doing subtraction. So for subtraction, you also need to have the denominators be the same. So let's see. What's a good one? 9, maybe 9. Now, since I'm a math major, I know that you're going to get a negative number here. just by looking at it, because this number is bigger than that. But we talked about negative numbers, so we can do it. So we have to find the LCM of 15 and 9. I'm going to do this the other way that you can do it, by doing the prime factorization. Oh, that reminds me, I'm going to try to make a video today about how to check to see if two numbers are prime, if my flash drive will hold that much. I've made a lot of videos in the past few days, for not just for this class, but for my other class. Alright, so least common multiple. Here we have 3 squared. Here we have 3 times 5. So for least common multiple, you take numbers that are in either one. Like, they don't have to be in both. Notice that there's no 5 here. 3's in both. 5's over here though, so you still need to take the 5. It doesn't have to be in both. And then you take the highest power, so we have 3 squared, so 45 is the LCM. So we want to make these be 45. So I have to multiply this by 3 over 3, and this by 5 over 5. So you get 21 over 45 minus 35. So same with addition. The denominator is just going to be the number that's in both denominators. Then on the top, you just subtract those two numbers. So you're going to get negative 14 over 45. And that's already in lowest terms. Okay, so that's addition and subtraction of rational numbers. So they require common denominator. Now, I know you're probably saying, well, yeah, it requires the least common denominator, but not really. It just requires a common denominator. So let me do an example where I pretend, this is pretend, I pretend, I talked in another video about, I'm not pretending, I'm imagining, something like that. But this is going to be pretend. I'm going to pretend I don't know how to find common multiples or common denominators. And I'm going to probably try to pick a big number, bigger numbers, not really big numbers. Okay, well, so I want the denominators to be the same. I can't add them together if they're not the same. I have no idea how to find common denominator. I skipped that day of class. So I can't do it, right? No, you can. You can just make the denominators the same. One of the easiest ways to do that is you just multiply this one by that one and this one by that one. So I'm going to multiply this like this, and this one over here like this. So 189 over something, I don't know what that is yet. 264, can you see this? Yep. What is 24 times 21? 484, 504, I believe. I hope so. Let's check. I have my cell phone here, so I can do what you do and use my cell phone as a calculator. I know I'm right anyway, but... Oh, I was right. Why am I always right? Close out all my apps. Alright, so now you can add these two numbers together. Oh, I might need my calculator again. Well, I know the bottom is going to be 504. I should just get out my actual calculator. Oh, there goes my Gatorade. Luckily, it had its top on. Alright, so here's my actual calculator. I don't really like using my cell phone. Cell phones are for calling people, which I do once a year. 453. Sounds right. Now, I'm going to tell you right now that that's probably not in lowest terms, since we didn't simplify. Now, these can't be simplified. 9 over 20, oh wait, 9 over 24 could be. 3 goes into both. So yeah, this is probably not in lowest terms. Matter of fact, if you use your divisibility rules, you can tell that each of these numbers is divisible by 3. Okay, so we want our answers normally, unless otherwise specified for some reason, to be in lowest terms. And I realize now that we'll probably have to do another video for these two because it just went over 16 minutes and it's not good to have a video that long. It's hard to upload to YouTube. And then if you made a mistake, you wasted, like if you make a 30-minute video and realize you made, not you made a mistake, but maybe like the sound didn't come out right or something, then it was a big waste of time. So 151 over 168, is that in lowest terms? Well, you know what? I think I'm going to do another video right now where I keep this number on the board and we're going to see if that's in lowest terms. And I'm going to talk about how to test to see if a number is prime. You don't really need to know that to check to see if this is in its lowest terms. But I'm going to put that in the same video. We're going to see if this is in lowest terms. It probably is. And then I'm going to talk about primality testing. And then we're going to come back and talk about this. But you can watch the videos in any order you want, really. So I'm going to erase this. Leave that there. Stop the video.